Jack planted a mysterious bean just outside his kitchen window. It immediately sprouted 2.56 centimeters above the ground. Jack kept a careful log of the plant's growth. He measured the height of the plant each day at 8 o'clock a.m. and recorded the data as follows. In order to talk about the height of the plant at different times and make predictions, we're going to start by writing an exponential function. Remember, the standard form of an exponential function is a times b to the x, where a is your initial value, b is your percent change, and x represents an exponent, in this case time. For this example, our initial value is 2.56 centimeters. B represents our growth rate, which we haven't figured out yet, x our amount of time, and our function equals the height after x number of days. We can use a second data point to help us figure out the growth rate of our plant. Substituting 2 in for time and 16 in for the height, we can now solve our equation for b using our solving equation steps. Undo the multiplication by dividing both sides by 2.56. Then, to get b by itself, undo the square by taking the square root of both sides. Now you have the growth rate of your plant and can finish writing your function. We can use our function to solve a variety of different problems. For example, Jack's younger brother decided to help and measured the beanstalk on the evening of the third day at 8 o'clock. Being the forgetful younger brother that he is, he forgot to document the measurement. Let's use the function that we came up with to help him figure out mathematically what the measure of the plant was at that time. From the problem, we know how much time has passed, but we don't know the height of the plant at that time. Begin by filling in x. We know that Jack measures the beanstalk at 8 o'clock each morning, so if his brother measured it at 8 o'clock p.m. on the evening of the third day, that's 3.5 days that have passed. Everything else you can do on a calculator. Don't forget your order of operations. You should raise 2.5 to the 3.5 power before multiplying it by 2.56. Take a moment to see if you can put this correctly into your calculator before the answer appears on the screen. If you're breaking this into two steps, you should get 24 and 71 hundredths, which you will then multiply by 2 and 56 hundredths. Your final answer should be approximately 63 and 25 hundredths. Does this answer make sense? Take a look at day 3. The plant's height was 40 centimeters at 8 o'clock in the morning, and on day 4 it was 100 centimeters. 63 and 25 hundredths falls right in between those 2 days, so it makes sense that it was at this height at 8 p.m. on the third day. Let's try a problem now where we're solving for time. This will involve logarithms. Using our function, let's figure out how long it will take for the height of the plant to triple. We know our initial value and the value that we're looking for, but we don't know how long it will take to get there. We're solving for x. Fill in the final height with 7 and 68 hundredths, followed by the rest of your function raised to the x. To solve this, we need to get x by itself, so begin by dividing both sides by 2 and 56 hundredths. It makes sense that 3 becomes our solution on the left-hand side because we tripled the height to begin with. Now the fun part. Take the log of both sides so that you can use our logarithm properties to take the x out of the exponent and put it out in front of the log. Now simply divide both sides by the log of 2.5. Since your logs are in base 10, you can use a calculator at this point to approximate your answer. Type in log 3 divided by log 2.5. Pause here to see if you can get the correct answer before I write it on the screen. You should get 1 and 199 thousandths. But what time does this actually represent? It's 1 and 199 thousandths of a day. But what is that? To find 199 thousandths of a day, simply take that decimal and multiply by 24. This will give you the number of hours that have passed. Your answer should be 4 and 776 thousandths, or 4 hours. But what's 776 thousandths of an hour? Can you figure it out? Did you get about 47 minutes? In order to find this, take 776 thousandths and multiply by the number of minutes in an hour, or 60. If a day begins at 8 o'clock a.m., this means the height of the plant will triple at about 12:47 p.m. Does this answer make sense? At the beginning of day 1, the plant has a height of 6.4 centimeters. We're looking for, shortly after that, when the plant has tripled in height, or is 7.68 centimeters. Logically, it makes sense that this would occur shortly after the beginning of day 1. Let's take a look at another type of problem that uses an exponential function and logarithms to solve. The half-life of an element is defined as the time it takes for an element to decay to half of its original amount. The half-life of carbon-14, for example, is 5,730 years. Writing an exponential function for this situation is a little different than the last problem because we don't know the initial amount. In order to figure out the decay rate, we simply need to pick an amount and then half of that resulting amount on the other side. A common mistake is to write the initial amount on the wrong side. Make sure that your initial amount goes in the position of A and your resulting amount goes on the other side of the equal sign in your function. It does not matter what two values you pick as long as your ending amount is half of your initial amount. It will always simplify to 1/2 equals your decay rate raised to a number of years. To find our rate of decay, we simply need to take the 5,730th root of each side. Try this on your own on your calculator now. You should get the following number. Be careful here. Your B value actually represents the amount that's remaining after each year. To find the actual decay rate, take 1 and subtract your B value. Let's put in some real values. For example, if I have 381.4 grams of carbon-14, and after a certain amount of time I'm left with 36.2 grams, how much time has passed? Here you're solving for x, or time. Begin by dividing both sides by 381.4. In order to bring the x down out of the exponent, we must now take the log of both sides. Using our properties of logarithms, we can now rewrite this logarithm with the x being multiplied out in front. To get x by itself, divide both sides by the log base 10 of 0.9999. Pause here and try this on your calculator first. You should get approximately 23,537 years. Let's try another one. Let's say you're starting with 46 grams of carbon-14 and you would like to know how much will remain in 1,481 years. Plug in your initial value and your time and then solve. Don't forget your order of operations. You need to deal with the exponent before you multiply by 46. You should get approximately 39.67 grams remaining after 1,481 years. Don't forget that your actual rate of decay is 1 minus your B value. Word problems like these take practice. Remember, first, write a function to describe the given situation. Then, identify what piece or pieces of information you have and what piece or pieces of information you need to solve for. Then, use your knowledge of exponents, logarithms, and solving equations to figure out the answer. If you would like to learn more about logarithms, check out the logarithm playlist.